Hello, in this video I want to show you how to filter an array in TypeScript and JavaScript because the logic is the same, and how the filter works internally. We will even write our own filter function so you can really see what's going on behind the scenes when you use the JavaScript or TypeScript default filter function. And we will even make our filter type safe. We will use higher order functions to implement the filter. This is crucial knowledge for every TypeScript and JavaScript programmer, so if you're not 100% comfortable in using higher order functions, watch this video. Oh, and make sure to hit the thumbs up and subscribe buttons right away. So let's define an array of numbers. Now we want to filter this array and receive only even numbers. For this we need to first create a function that determines if a given number is even. A number n is even if n modulo 2 equals 0. The percentage sign means modulo, and modulo gives you the remainder of an integer division, n divided by 2. So if the remainder of this division is 0, the number is even and the function will return true. Now we have to apply our filter function to the array of numbers. Every array in TypeScript and JavaScript supports a method called filter that takes as argument a function definition. The function will be called for each array element and will return true for all elements that we want to have included in the result. In our case, those are the even numbers. Observe how we use the isEven function as a parameter of the filter method here. Now let's try that, and it works. So how does this work internally? Let's try to implement our own filter function by taking baby steps. First, I will implement a very explicit function called getEvenNumbers. We define a result array that will be returned by the function in the end. And then we fill the result array with all even numbers. For that we loop through all array elements, and for each element, let's check if it's even. We do this by using the same modulo condition in the if that we already used in our function discussed earlier in this video. If the current number is even, we push it onto the result array. Let's try this. And it works. However, this is obviously not a good implementation of filtering because that one function we just wrote contains the logic for exactly one filter. The JavaScript and TypeScript designers needed to come up with a more versatile solution. The key is not to directly hardcode the checking condition within the function. We need to exclude the checking condition and take it as a parameter to the filtering function itself. So let's create a new function. I'll just copy and paste our last function and change the name to filterNumbersArray. Now, as I said, we want to have the condition as a parameter for our new function. We do this in TypeScript and JavaScript by accepting a function as a parameter. Let me repeat this slowly. I will now introduce a parameter that is of type function itself. And not just any function. We want the condition to be a function that takes a number as a parameter and that returns a boolean. One has to get used to this syntax, but this is how you can receive a function as a parameter. Now, instead of the hard-coded condition, we just call our filter function that we got as a parameter. This takes the number as a parameter itself and returns true if the condition inside the function is fulfilled, which indicates that the current number should be pushed to the output. And if you want, you can shorten this condition here. Let's try that. It works. What we did right now works only for number arrays. But the general filter function works for all kinds of arrays, booleans, strings, numbers, and so on. One way to extend our function to work with also all the other kinds is to use the TypeScript anyType instead of numbers, just like that. Let's copy and paste our latest function and let's rename it to filterArray. Then we change all the type references from numbers to any. Let's try that. It still works. And now we could even use this filter function to filter arrays of strings. For example, let's define an array called texts with some random text snippets. As we did for numbers, we create a filter function for strings. For example, let's create a function called isLongString and say It returns true if a string has more than 5 characters. Using our filter function, we can now filter this array and only get back long strings with more than 5 characters. So let's check that out as well, and it works. Of course, using any can be considered problematic in TypeScript. For example, with this implementation, I could apply our numbers filter function to the string array, or I could apply the string filter function to the numbers array. This doesn't make any sense. The really bad thing with these kinds of implementations is that while developing, everything seems fine, but it takes only some small mistakes and your program could behave completely weird and you'll need hours and hours to debug where the problem is. Luckily, we can get rid of that problem right away. Let's use the power of TypeScript generics. Before that, let me clean up the code a bit. And here we are. So once again, we copy our last function definition and rename it to filter array TypeSafe. Then we use a generic type. Let's call it type of the array. This type of the array can take any type like number, boolean, string, whatever you want. Now we apply this type to the array, to the element that the filter function expects, and the return type of the filtering function. This basically means that whatever the type of the array is, all those 3 things need to have the very same type. If one of them is number, all of them have to be numbers. Let's see how this looks when we call the function. Now we get an error right away at design time. The IDE tells us that the parameter should be of type number, but we used string instead. Think of how bad it would have been to apply a wrong filter function that might lead to weird results. Let's correct this mistake. Now the error is gone. We can observe a similar behavior when we try to use the built-in filter function. Also here, TypeScript makes sure that we use the correct filter for the type of the array. One more thing. Normally when using generics, we just use the letter T for the type instead of our long name type of the array. Let's do this so we apply the common coding style. Anyways, the functionality stays the same. So the main takeaway from this video is that in TypeScript and JavaScript we have the ability of using a function as a parameter for another function or a method. This way you can parameterize not only data, but also logic. If you got some new insights to TypeScript and JavaScript programming, please support me and hit the like button, subscribe to the channel and share this video. See you soon and happy coding!